Welcome one and all. So in this today's lecture we will discuss about one of the topics known as exact differential equations. In this one we will discuss what is the general form of a exact differential equation and how to identify that, and what is the general solution, how can we evaluate the general solution of for that. All those things we will discuss today. So first of all, let me tell you about what is the general format and how we can identify an exact differential equation. Suppose if we have a differential equation of the form sum m of xy dx plus n of xy dy is equal to 0. Suppose whenever we identify any differential equation in this form, simply we will call it as m dx plus n dy is equal to 0. Whenever you will find any equation in this form, then how to identify whether this is exact differential equation or not, and if it is exact, then what is the general solution. So actually we have so much of background theoretical part is there for this exact differential equation, but I am directly coming to the point how we can identify, and then if it is exact, then what to do the procedure and all that only now I am covering in this video. Okay. So whenever you find any equation in this form, simply m dx plus n dy is equal to 0, then our first aim is just to identify what is dou m by dou y. Means if I have to find out the partial derivative of m with respect to y, and similarly we have to find out the partial derivative of n with respect to x, and if we identify that these two are equal, then we can say that this equation is nothing but an exact differential equation. So once if you identify that any equation is an exact differential equation, then the general solution is given by integral m dx. So here in this integral we have to treat y as a constant plus integral of, here we have to collect the terms in n which are free from x. So means integral of the terms in n, means the function n which are free from x. Which are free from x into dy is equal to c, of course, where c is nothing but an arbitrary constant. Once again, if we identify that dou m by dou y is equal to dou n by dou x, then we can say that that equation is nothing but exact. Then the general solution of the equation is given by integral over treating y as a constant m dx plus integral of the terms in n which are free from x into dy is equal to c. So before going to discuss about all these things, may not be the entire theory, simply with the help of one example. So let me tell you the exactness for a differential equation. Suppose for example, very simple thing we will discuss. Suppose if we have a differential equation like this, x dy plus y dx is equal to 0. Suppose this is a differential equation. For example, we have, now you may feel that that can be solved easily by using variable separable we can solve, homogeneous we can solve, like that so many methods we can solve. But here we have a function xy, so that the differential equation can be written as derivative of xy. Okay, so this type of equations are nothing but known as the exact differential equations, because this entire differential equation now can be expressed as some exact differential of some function. Here what is that function? Xy. So the exact differential of the function xy is nothing but the given differential equation. So once if we can express like this, then if you integrate this one on both sides, then easily integration and differentiation cancels out and we will get its general solution as xy is equal to c. Okay, so but every time we cannot guess like this. Every time it is not possible to identify a function for which the exact differential is nothing but the given differential equation. So that's why after doing so many theoretical procedures and all, they have identified one procedure. So that procedure is nothing but just whenever the equation is in this form mdx plus ndy is equal to 0, some certain procedure is given just like as what we have discussed. So by using this procedure we can identify whether dE is exact or not. If it is exact, then we can find the general solution like this. Okay, so or otherwise if we can directly identify for any differential equation like this, so we can directly do that. So nobody can stop us to identify and directly to find the solution. Okay, now we will see this concept with the help of one example. Suppose for example if we have an equation like this. Okay, so now if you observe, this equation is in the form of, so suppose some m, you can treat this one as m dx plus n dy is equal to 0. Okay, so now let me take this equation as some equation 1. Okay, now you may write it as something, so equation 1 or otherwise the given dE. Equation 1 is of the form, simply I am writing like this without intimating writing the parameters. M dx plus n dy is equal to 0, where m is equal to, what is m here we have, if you identify, here we have 2x cube minus xy square minus xy square minus 2y plus 3, of course, and n is equal to, here we have negative sign, so that's why you multiply with that, minus x square y minus 2x. Okay, now we will check whether it is exact or not. Okay, so for that now you find the partial derivative of m with respect to y, then that it is nothing but dou m by dou y. So here to solve the exact differential equations, one should have minimum the basic knowledge in the partial differentiation, otherwise it is not possible. So now dou m by dou y is equal to, so here, so partial differentiation means, let me tell you simply about that, whenever we are partially differentiating a function with respect to one variable, so here I am partially differentiating m with respect to y, means in this situation we have to treat all the remaining variables as constants. Okay, means here x is nothing but treated as a constant, so means the derivative of 2x cube is 0, minus here also in the second term also x is a constant and derivative of y square is nothing but 2y, because we are partially differentiating with y, minus 2 into derivative of y is 1 plus derivative of 3 is a constant. So means now finally we get dou m by dou y is equal to minus 2xy minus 2. So similarly we will calculate dou n by dou x. So the partial derivative of n with respect to x, means here we have to treat y as a constant. So here y is a constant, minus y is constant here, so derivative of x square is 2x, minus 2 into derivative of x is 1, so which is equal to minus 2xy minus 2 we get. So if we observe here, so dou m by dou y is and dou n by dou x both are same, so therefore here we can conclude that dou m by dou y is equal to dou n by dou x. So means there we can conclude that therefore equation 1 is exact, or otherwise we can say that equation 1 is an exact differential equation, like that also we can conclude. Therefore we can find out the general solution as we have discussed in the previous slide. What is the general solution? The general solution is given by integral over treating y as a constant mx dx plus integral of the terms in n which are free from x into dy is equal to c. So by using that, here may I write, therefore the general solution of equation 1 is integral over treating y as a constant m dx m dx plus integral of, here we have to write the terms in n which are free from x into dy, of course, is equal to c, where c is an arbitrary constant. So this implies integral over treating y as a constant. Now you observe what is m here. So here we have m 2x cube. So it is 2x cube minus xy square minus 2y plus 3 into dx plus integral of the, in n we have to select the terms which are only free from x. So means here in n there are no terms which are free from x. Here also we have x square term and here also we have the x term. So therefore simply here we can take 0 because there are no terms which are free from x. Okay, is equal to c. Now here we just integrate this, then here we have integral of x cube is x power 4 by 4, so 2 into x power 4 by 4 minus here y square is a constant, we have, because we are integrating by treating y as a constant, so there is 4y square into, so integral of x is x square by 2 minus here 2y is a constant, means 2y, the integral of constant means 2y into x plus 3 is also a constant, means 3 into x is equal to c. Already here we wrote an arbitrary constant, integral 0 means that is also a constant. So just you can simplify this, then we can write it simply, you can write x power 4 divided by 2 minus x square y square by 2 minus 2xy plus 3x is equal to c. So this is the general solution of the given differential equation. So once if we identify that the given differential equation in the form of m dx plus n dy is equal to 0 is exact by evaluating the partial derivatives dou m by dou y and dou n by dou x if both are equal, and then we can find out the general solution by using this formula, and here for this problem we got the answer like this. So similarly we will see one more some typical problem where the partial differentiation will have some importance here. This is a very simple problem. Now we will go with one difficult type of problem. Okay, so here the problem is something like this. Some y square into e power xy square plus 4x cube dx plus 2xy into e power xy square minus 3y square into dy. So let me take this problem as some equation 1. So let us follow the procedure. So once again here write equation 1 is of the form some m dx plus n dy is equal to 0. So where, so here whenever we will compare the equation with this standard form, we get here m is equal to y square into e power xy square plus 4x cube, and n is equal to, n in the sense n of xy, n is equal to 2xy e power xy square minus 3y square. Okay, so these are m and n. Now we will find out the partial derivatives with respects to y and x respectively. Now first of all we will find the partial derivative of m with respects to y. Means now we are going to calculate dou m by dou y. So dou m by dou y is equal to, so here we have two terms, in both the terms we have y, so therefore here we have to apply UV rule. So first of all we will take derivative of y square, derivative of y square is 2y into e power xy square, plus now you leave y square and find the derivative of e power xy square. In e power xy square also we have y square term, so first of all it is of the form e power x, means derivative of e power x is e power x, in the sense e power xy square, into derivative of xy square also we have to calculate, and while calculating that here we are calculating partial with respect to y, means x is a constant, so means x you leave that x, and derivative of y square is 2y. So this is how we can find the derivative of the first term y square into e power xy square. So let me explain once again. So here we have to apply UV rule for y square into e power xy square, and first of all derivative of y square you calculate, that is 2y into e power xy square plus y square, now you leave it, and the derivative of e power xy square, e power xy square into, if we have to apply the chain rule here, so xy derivative of xy square is nothing but x into 2y, because x is constant and derivative of y square is 2y, plus derivative of 4x cube we have to calculate. So we are partially differentiating with respects to y, so means x is a constant, means derivative of 4x cube is 0. Okay, now from these two terms we can take e power xy square as common. So if you take e power xy square as common here, then what remains here? In the first term we have 2y, and here we have 2xy square into y, means 2x into y cube. This is the partial derivative of m with respect to y. Similarly, we will calculate the partial derivative of n with respect to x. Okay, so here we have 2xy into e power xy square. So here y is a constant, in the sense 2y is constant here, because 2 is also a constant, into, now we have to find the derivative for x into e power xy square. So with respect to x we have to calculate. So first of all I will calculate the derivative of x as 1 into e power xy square, plus leave x, and derivative of e power xy square is e power xy square. Now by you apply the chain rule, or otherwise by applying chain rule, here y square is constant, so derivative of x is 1, so 1 into y square, minus, so here, so this first term is over. Now minus here, partially we are partially differentiating with respect to x, means y is a constant here, means 3y square term is a constant, means its derivative is 0. Means here also you can take e power xy square as common. If you take e power xy square as common here, then what remains? 2y. If you want you can multiply, because in the first term we wrote like this, 2y, plus what else is remains here? 2y into, here we have xy square, means 2x into y square into y, means x cube, y cube. So 2y plus 2xy cube here we have. So if you observe, both are nothing but same, so therefore we can conclude that dou m by dou y is equal to dou n by dou x. So therefore we can conclude that, therefore equation 1 is exact, or otherwise we can write, we can conclude that it as, so the given differential equation, equation 1 is an exact differential equation, like that also we can conclude. Okay, now after identifying that the given DE is an exact DE, we can find out the general solution as, so therefore the general solution of equation 1 is given as, what is the formula here? We know that integral over treating y as a constant, m dx, plus integral of the terms in n which are free from x into dy is equal to c, where c is an arbitrary constant. Now we will substitute this m and n as per the formula. We can write integral over treating y as a constant. M means here, what is m we have? So y square into e power xy square. So y square into e power xy square plus 4x cube we have there. So plus 4x cube whole into dx plus the terms in n which are free from x. So here if you observe in n, in the first term we have 2xy into e power xy square. So here we have x term, but in the second one minus 3y square, there is no x in that. So therefore here we can take minus 3y square into dy is equal to c, where c is an arbitrary constant. Now here you find, if you find the integration for this, so here y square is a constant. Now here it is very important, integral of e power xy square, but y square is a constant, means it is of the form some e power kx. So the integral of e power kx is, what is integral of e power kx? E power kx by k, means here what is the k here? Y square, means it can be written as e power xy square by y square plus 4 into integral of x cube is x power 4 by 4 minus, if you come to this, integral of 3y square means 3 is a constant and integral of y square is y cube by 3 plus is equal to c. Okay, so here all the things will cancel out, and if we offer the simplification, we get the general solution for the given dE as e power xy square plus x power 4 minus y cube is equal to c. Okay, so this is how we can solve an exact differential equation. Thank you one and all. Thank you very much.